Hello everyone, and welcome to another Leetcode video. Today we're looking at the problem maximum frequency of an element after performing operations 1, which was question 2 in Biweekly contest 143. This was a pretty difficult Q2, probably one of the hardest ones in a while, so just wanted to share my solution, and hopefully it helps some people out. So the question reads that we're given an integer, array nums, and two other integers. We're getting k and also num operations. We must perform an operation num operation times on num, where in each operation we have to select an index that has not been selected before, and we can add an integer in the range -k to k to that nums. And the goal here is that we want to return the maximum possible frequency of any element in nums after performing that operation. So in this example, you can see we have the array 5, 11, 20, 20. Our k is 5. This means that for any element in this array, we can either add 5 or remove 5 essentially. So this 11 can go all the way down to 6 or go up to 16. And we can do this operation one time. So our output here is actually going to be 2. And why is it 2? Well, we're getting that because the most frequency that we can have is actually these two 20s right here. Right? You can see that any other operation that we apply, we actually can't make any other frequencies the same, right? We could add 5 to this 5, but that would be at most 10. We could add 5 here, but that's at most 16. So what we actually end up doing is adding 0 to this 11, and then just keep these two remaining 20s here. Let's look a bit closer at how we could solve this. Just looking at the example 145 with our k being 1 and num operations equaling 2. So just a reminder, k is the amount that we can subtract or add to each element, and our operations is just the number of operations that we can actually do. So in this example, the optimal solution would be to either add 1 to this 4, right, will just become 5, or we could subtract 1 from this 5 and get a 4, right? So those are the ways that we can accomplish this. But how do we actually solve this problem? Well, what we could do is say we're just on an element here, right? How would we go about figuring out what other elements we can change in order to make them 4? Well, we could just iterate through every other element, right? So say we're on 4, we could go to 1 and say, can I add k and can I get to 4? Well, no, I can't, so we can move on. We can go to 5 and say, can I add or subtract k and get to 5? Well, I can, so I can keep track of 1 here, right? But this is going to be way too slow because basically for each element in the array, we have to go through every other element, which is going to be O of n squared. So this is not going to pass, and we can definitely do better than that. Another option might be to sort the array. So this array is already sorted, but you can imagine if we have an array in sorted order, well, the numbers that we can change are going to be the ones that are on our right side directly or on the left side directly. So starting from here, we could go right and keep going until we hit an element that we cannot subtract k from. Likewise, we could go here and we could also find the element that we can't add k to get to 4. But again, this could potentially be O of n squared because our k could be very large. We could go all the way to the end of the array, all the way to the beginning of the array every time, which would end up being O of n squared again. There has to be a better way that we can do this. So one thing we can do is actually keep counts. So we're going to have an array, and what we're going to do is count the number of times that each element occurs. So 0, we have 0 times. We have 1, 1. We have 0, 2s, 0, 3s, but we have 1, 4, and 1, 5. So how does this actually help us? Well, for example, say we're looking at the element 2, right? What we could say is, well, I know that at 2, I have 0 elements, but 2 minus k, I could potentially change to get to 2. So what does this mean? Anything that is between the range 2 minus k, which is 1, and 2, could potentially become 2. Also, 2 plus k equals 3, right? So anything in the range from 1 to 3 here, we could potentially update to become our 2, right? So we have the counts. So if we know the range that we could operate in, we could essentially find how many are in that range. But again, so say we have a very large k, and we're looking from 2 or 2 to minus 1,000, 2 to plus 1,000. Do we have to go through every single element and count how many times they occur? That's kind of a waste of time. So what we could do is we could use prefix sum. So what does prefix sum look like? So we'll have here, we're just going to add up the number of times that our elements occur and do it cumulatively. So we have 0, we have a 1 here. So now going forward, we're going to just carry over whatever we have. So we have 1, 1, we're going to add another 1, 2, 3. So this here is our prefix sum. So how do we actually use this prefix sum? Well, let's say again, we're looking at 2, right? We know that basically everything in the range from 1 to 3, we could potentially update with our operation to make it equal to 2. And now we can find this in constant time, right? Because what we can do for prefix sum is we could take our 3, this is the upper limit of our range, then we could take the lower limit, which is 1 minus 1, and subtract it. So now here what we're saying is that we have 1 minus 0 elements that we can update. And this is true, right? Because we see that we have 1 in our array, we can add a 1 to this, and that will become 2. So basically what we're doing here is we're going to use a prefix sum, and then we're just going to iterate through each element using our prefix sum to find the number of operations in constant time that we can update. So one other thing we have to consider is this num operations, because you'll notice we haven't used this yet in any of our logic here. So where does this come into play? Well, let's say, for example, this was 8, right? And say we had a lot of potential operations that we could make here. But you'll see that we only are able to actually do 2 operations. So really what we want to do is we need to compare our number of operations to how many operations we actually can make. If the number of operations that we can make is greater than a number of operations, we have to limit it to this value, right? Because we could potentially do 8, but we know that we can only actually do 2 according to the rules of the problem. So we have to do this comparison whenever we're actually deciding on our answer. So overall, this is going to be an O of n solution. And why is it O of n? Well, it's O of n because we go through the element one time to do the counts, then we do another O of n to do our prefix sum, and then we do another O of n to actually go through, calculate our sums, and then record our answer. So here what we have is O of 3 to the n, but in big O analysis, we can cancel out this constant, which will just give us O of n. Let's hop over to the code and see exactly how this works. So the first thing we're going to do is set up our counts array. And we're going to make this an array of the length max nums plus 1 plus k. And I'll explain how we come to this. So remember, say the maximum element in our array is 5 in this example. Well, if our k is 3, this means that potentially our values can go up to 5 plus 3, which would be 8, right? So this is why we're taking max of nums plus k. But remember, if our maximum element is 8, that's going to be the index of 7, right? So we have to account for that with this plus 1 for zero-based indexing. Then what we're going to do is just go through nums, and we're going to count the occurrences of those numbers. Then we're going to start our prefix sum. So we're going to start with the counts of 0 from our counts, and then for each element from 1 to the end, we're just going to update our prefix sum with whatever value that we see. So now we're actually going to go through the array again and keep track of our answer. So for every element in the range from the length of counts minus k, and why do we use this value? Because remember, we're going to be adding k and accessing that index, right? So we don't want to go out of bounds, which is why we have to subtract out k in the range of indexes that we're going through. Then what we're going to do is we're going to have our left value be the maximum of 0 to I minus k minus 1. So in the early stages of our iteration, this could potentially be less than 0, right? So you can imagine if we're on the 0th element of the array and our k is 3, we're going to be at the -3rd index. So what we want to do here is if we're out of bounds in that way, we're just going to keep the 0th index here. Similar on the right, we're going to usually use our I plus k index, but if that is out of bounds on the right side of the array, we just want to use the last index in the array. Then we're going to keep track of our mid count. And basically, this is the count of the element that we're trying to change other elements to. So in our example, say we use the mid of 2, and all the elements from 1 to 3, we try to converge onto this value. So that's what our mid represents here. So the number of elements we can converge is the number in the right, the number in the left, minus our mid value. So essentially what this is telling us is that we could potentially have up to right values. We have to minus these left values because they are not in our range, but we also don't want to consider the ones that we're changing to, right? So say we have 2 2s already and we're looking at 2, we don't want to consider those as conversion because they're already the same frequency. So we could just subtract those out. So if our convertible amount is greater than the number of operations, remember, this is where we might have some larger amount that we can change to our current value, but the number of operations limits it. So what we do is we update our answer to the max of whatever answer we've seen before, our mid value plus number of operations. Otherwise, if we're not limited by number of operations, we'll just update our answer to be the maximum of answer or mid plus however amount we can convert. Then at the end, we just return our answer. So let's submit and make sure that this works. And it does work, so hopefully this is helpful. If you like the video, please like and subscribe, and thank you for watching.